Hey guys, I hope you guys are doing good today. At the heart of observability, there are two key concepts, which is traces and spans. Think of your daily routine. Your entire day from waking up to going to bed represents trace, a complete journey. Each activity is like having a breakfast, going to work is a span. Specific task within that journey. These concepts are crucial in understanding how different components of systems work together. For instance, if an app is slow, the traces and span helps pinpoint the exact steps causing the delay, just like identifying a traffic on your drive to work. In the video, we will explore traces and span in detail using a relatable examples and their connections to entire world application performance. Let's take this real-time example for traces. Basically, daily routine. Imagine a day of your daily routine. You wake up, get ready, eat breakfast, drive to work, attend meeting, come home, having dinner, and sleep. Trace represents entire sequence of your activity during the day, from waking up to going to bed. It's a high-level view of your daily journey. Let's take this example for this plan. Okay, so the activity is broken into steps. Wake up, alarm rings, brushing teeth, breakfast, preparing and eating breakfast, drive to work, starting a car, navigating a traffic and reaching office, lunch, ordering and eating food, meetings, joining calls or in-person discussion, drive back home, navigating traffic again, dinner, cooking or ordering food, and eating. So, what exactly it says about each activity, wake up, breakfast, or drive, etc., is a span representing a specific part of your day. Spans provide a detailed insights into the traces. Let's talk about what is trace in observability in a technical space. Trace is a representation of entire life cycle of request or transaction, showing the path it takes across different service or systems. Your daily routine is the trace that encompasses all activities, basically spans. Example, a trace shows the end-to-end flow of your user request across microservices. Now let's talk about something in span. Span is a single operation or task within a trace. It provides metadata like starting time, duration, and error status. Each activity like waking up, having breakfast is your daily routine is a span. When user logs in, request span could include fetching a user data, validating the credentials, and loading the home page. How trace and span work together in observability. Imagine driving to work, entire journey, home to office, which is known as trace. Individual steps like starting the car, navigating traffic, and parking, which is known as a spans. Heavy traffic on the way, which is delay in reaching office, missing meetings, and an unhappy boss. The ripple effect reduce your productivity and enthusiasm. Now let's have some connection with an observability. If database query or microservice is slow like heavy traffic, it affects the entire trace. Observability helps identify which span caused the delay, so it can be easily optimized. Latency and the frustration. If your car breaks down or traffic is heavy, it is longer time to reach your destination. How exactly this impacts you? This literally frustrates you. A similar example is like a frustrated user waiting for an app to load. How we can relate this to our technical example? When a database query took long and user experience latency and resulting in poor experience. Let's talk about parent and child span. Parent span represent the primary task or overreaching process. Child span is a subtask or smaller steps within the parent span. Let's take an example as a drive to office, which is a parent span. Child span is all about starting the car, navigating the traffic, parking the car. This is all about child span. Let's put something in more granular in a technical perspective, like user login request is the parent span. Child span is known as validating the credentials by using an auth service like LDAP or DB or whatever it may be, fetching the users from the LDAP and then rendering the home page. Basically, it's landing to the front end landing page. Let's have one more example. Say, for example, placing an online order for food. Parent span represents overall process of placing an order. This is the main activity or request. Child span represents break down the process into smaller tasks. Say, for example, browser menu, user selects the item from the menu, add to the cart, items are added to the cart, and total is calculated. Payment processing, payment is verified with third party API payment gateway, and order is confirmed. The confirmation order and notifies to the user. Let's talk about something on parent ID and child ID relationship. Parent ID and child ID are used to establish relationship between spans within a trace. Let's break down. What is parent ID? Parent ID represents identifier of a span that initiates or oversees a specific task. It is the span that calls or trigger another span. Child ID represents the identifier of a span that is depend on parent span. So it is the span that performs a task as a part of parent's larger operation. How exactly it's going to help? Say, for example, each span in a trace has unique identifier called span ID. A parent ID links a span to an originating span and creating a hierarchy or tree-like structure. Let's take this example. Parent span placing an order with the parent ID called 1001, and child span has a lot of spans: browser, menu, add to the cart, payment processing, order confirmation. Each child has their unique ID. Say, for example, browser menu has 1002, add to the cart has 1003, payment processing has 1004, and order confirmation has 1005. Each child span has a unique ID, which is a parent ID. It has also mapped. What exactly this is going to explain? Parent ID 1001 links all child span to overarching task to placing an order. Each child ID is a unique to its respective task but put back to the parent ID, maintaining the tree hierarchy. In a technical perspective, in a distributed tracing system, trace ID remains the same across all span in a trace. Each span has its own span ID and reference its parent ID. This linkage helps observability tools build a visual tree of how request flows across different services. So now you would have learned how traces and spans helps in observability. Reinforce the analogy of your daily routine to clarify the concepts. Encourage viewers to explore distributed tracing tools like Jigger, Zipkin, or AWS X-Ray. Do you want to get more content like this? Then you have to subscribe my channel. Please do subscribe it.